Hi, good day, everyone. So, here we are for another one in the video series. And right now, we're tackling lab number 9, which is on refraction. I think this video might be a little short, but we'll see how it goes. So, lab number 9, this is refraction. Remember, light. We made this amazing observation about light that as it travels from one medium to another medium, it bends, right? It does not continue in a straight line. All right. And this was what we fully experimented with. And then there was a brilliant fella named Snell who came up with, well, he was not actually the only guy. There was somebody else that actually came up with the relationship, but he was, I guess his name was end up getting credited to it. But yeah. So we have Snell's law right now, which is that the for a given pair of mediums, that the sine of the angle of incidence, the sine of the angle of refraction is a constant. All right, so let me look at this. The thing that we need to do, gradient calculation. Well, you all should be able to do that. We had a video on gradient calculation, so that should be like food and fodder. Then we have up next, we have is the refractive index, yeah, that we need to be able to find that calculation for. I have derivation, but the derivation is like almost non-existent, to be honest. So we have sine I, um, and then we have sine R. Okay, so and then we have this graph is going to be something like this. Bam. All right. Now, what do we need to do? We need to ultimately, the aim of this lab is to determine the refractive index of a glass block. So let's see how we are going to get the refractive index. So we have these measurements. We don't have theta. We have replaced them. They should be replaced with the letter inside the lab, which is I and R. So we have the angle of incidence and the angle of refraction. All right. And all right. So the way that we actually going to go about this, calculating this, we're going to do sine I over sine R is equal to M, equal to the gradient. All right. From the physics half of it, so on the physics half, we know that sine n1 sine I is equal to n2 sine R. All right, so we just need to put this in I over R. All right, so sine I over sine R is equal to n2 over n1. All right, and this is what we have, right? So we could equate these two, right? We have this equation, we have this, equating equation 1 and 2, equating equation 1 and 2, we have m equals n2 over n1. Then we will say naught n1 is refractive index of medium 1 in brackets here, n1 equals 1. Therefore, m equals n2. n2 equals whatever you find that to be, right? Equals your gradient, right? Whatever your gradient is. So don't actually write gradient in that box, write in the number. So n2 is equal to that. n2 is, if you want, right? n2 is refractive index of medium 2 brackets glass. That's the derivation. That's the calculation. N2 equals how much you need. So if you really, I guess, want to keep things looking a certain sort of way, N2 equals this, right? N2 equals box. Bam. Um, or you could put this up there too. So and then that is it. Then you could do discussion. Was the state the laws of refraction in your own words? You got the two laws, and then state in words, and then state the Snell's law formula. All right. Precautions, so, conclusions. All right, and that is it. All right, guys. So I will see you on in the next one. Later.